So thank you all for joining today. As the online map team, myself, Gino, Kim, and Taylor will take you through our final results for the business case that Greg presented to us at the beginning of the semester for depot autonomy. So jumping into the agenda that we have to go through within the next hour, we'll just go through the project overview and the tasks that our team was set with. We'll take you through the market analysis and trends we've identified. Kim will walk through the opportunities for depot autonomy. Taylor will walk through the financial model. And finally, Gina will take us through key recommendations and next steps. And then there will be time for questions at the end. So with that, just reiterating the project that our team was tasked with. So we were tasked with two main objectives related to depot autonomy. The first being to develop a strategic market analysis by identifying the competitive landscape and volume potential. And the second being to create a tactical business case through producing a financial model, which would estimate the profitability of implementing depot autonomy. So the scope of our project consisted of doing this thorough market analysis, identifying target customers and the positioning, and financial opportunities. And then throughout the semester, what we've developed, we will submit for our class and as well as to you, the final report, which goes into more detail of this presentation, the soft copy of the developed financial model, and then we will share this final presentation as well. So diving into the market analysis and trends, for depot autonomy, we've identified that the fulfillment centers market would be best suited, and where we see that the value is roughly at $90 billion and has a compounded annual growth rate between 8 to 10%. Depot autonomy the technology related to depot autonomy would roughly impact 10,000 fulfillment centers. And on the right, you can see that there's the US logistics automation market, which would consist of a lot of the tools that depot autonomy requires, is also growing. So within the US fulfillment market, you'll see that we've identified that the last mile business to consumer would be really the market that the subcomponent of the fulfillment market that depot autonomy would really have the greatest impact. The value of this market is roughly 37 billion and similar to the fulfillment market, also has a compounding annual growth rate of 5%. Within the market, a lot of companies, their costs account towards labor, which is roughly 20 billion. So if we're implementing depot autonomy for this market, we would see a decrease of 7%, providing the total addressable market to be 1.4 billion. A lot of the companies within the market rely on custom OEMs and would be likely to implement depot autonomy. So that would leave roughly the serviceable addressable market at 560 million. As we did a lot of our analysis, we really looked at Amazon, as this is one of the largest companies within the market and has a lot of data easily accessible. So if Amazon were to implement depot autonomy, they would roughly save $350 million annually. As we looked at the market, and we identified that one of the major trends impacting the market was labor shortage. A lot of these companies, such as Amazon, UPS, are experiencing high workforce shortages. So really, this is kind of reiterating the need that depot autonomy has within this space. And as you can see on the chart on the right, there's been a significant increase within warehouse employment between 2019 and 2002. However, we're starting to see that trend decline, further reiterating the need for depot autonomy. And when we look at some of the results from this labor shortage, we would see that there is a significant increase in fulfillment times, roughly by 60%, leading to customer dissatisfaction, a loss of revenue, an increase in operational costs for overtime pay that employees are now working towards, given that there are less employees within the delivery centers, and then a disruption to the supply chain given the disruption to labor. So now that we've identified the trends and the market and the full market for depot autonomy, I'll pass it to Kim to take us through the opportunity.
As we're considering the opportunity, we took a look at the customers, the challenge, and how the challenge is being addressed, answering questions that were posed by the leadership of Mcity. So taking a look at some of those questions, who are the customers of depot autonomy? And we answered organizations which are operating within controlled environments, relying on labor-intensive operations to perform key functions. We took a look at some of the ideal customer traits and some of the traits to avoid. Now, these are ideal. It doesn't mean all customers would have all of these traits. For example, Amazon is not highly vertically integrated in that the drivers are contractors, but because of its scale, it still would have the ability to benefit tremendously and has a record of working closely with contractors in a way that it could be a feasible customer. But in general, these are the ideal customer traits. Also, some concerns if they're using multiple other companies in partnerships and they're not tied closely, the technology could have safety issues or not be as economically advantageous. Next slide. So taking a look at some other options who would be vertically integrated delivery companies, the United States Postal Service, FedEx, UPS, and DHL are just a couple examples. Our next slide, we take a look at who are the competitors. And while depot autonomy is a new concept, there are a number of companies specializing in similar automation that we've identified that should be reviewed as Mcity moves forward and are also potential partners as technology is developed that should be researched and looked at. Some of the direct competitors, Outrider, ISEE, and Easy Mile. Next slide. Taking a look at the unmet need and how customers are currently addressing it. Currently, there's no technology like depot autonomy is suggesting be created in use. So there's a gap in the market. And as a result, the companies are forced to use labor and put a lot of pressure on the workforce. At Amazon, they have a really high rate of labor turnover because of this. They're seeing difficulty recruiting employees. They are experiencing high costs and limited productivity because they don't have this technology. So the need is there. Next slide. We interviewed Amazon drivers and also looked at YouTube videos, taking a look at day in the life, to map out the time that is used in the beginning of the day that depot autonomy at an Amazon delivery center would help to make more efficient. And this is what the current process approximately is. If you take a look at the different segments, depending on how far depot autonomy's technology goes, you could use these timeframes to calculate different amounts of labor savings. We focused on 2, 3, and 4 as areas where there would be significant savings. On the next slide, we take a look at a proposed process if Amazon vehicle loading was automated through depot autonomy, and potentially delivery drivers' day of preparation time could be cut by about 25 minutes, and depot autonomy would allow for trucks to be prepared the night before. Preparation times would be reduced to approximately an hour, saving labor costs. Next slide. These are a look at our sources, people we interviewed and spoke to as we were putting all of this together for future reference.
All right. So, as we go into like what is the solution as described to us. So, depot autonomy was pitched to us when we first met with Greg and a lot of the engineers on the team is trying to automate these operations. So, where the vehicle is stored overnight, loading the vehicle, possibly charging the vehicle. There's a lot of holding processes and cleaning, inspection, repair, those types of activities. So the idea would be to have the vehicles marshaled through a well-defined area and minimize as much of the complexity and labor as possible. So the model itself operates by figuring how much time could be saved and then what those labor charging savings would be. Let's go to the next slide. So we looked at a lot of different variables for how to implement depot autonomy and the variables that are important to depot autonomy at specific delivery centers. So we looked at workforce compensation, how many of the employees are Amazon employees versus DSPs, or how many are warehouse workers versus the delivery drivers or managers, what the turnover rate for each of those employee types is, the compensation, like the burden compensation rate, the equipment that they're using, how are they actually performing the work. Operationally, we looked at whether the packages are being loaded in a traditional like bay, you have a loading bay, or what Amazon does is they have waves of delivery. So all the vehicles are moved into a delivery area at the same time. They load all the vehicles at once, and then they ring a bell, and all the vehicles drive away at once. So we created the financial model to be able to do either one of those um, uh, methods for loading the vehicles. The space is really important for understanding how uh, much the solution is going to cost. So if you look at the LiDAR and radar and range for each of the nodes on the solution, the space layout plays a large factor in your cost to implement the solution. We thought that there would be more nodes needed indoors because there's going to be walls and other types of obstacles to see around. And then we looked at what is the hardware cost? How much does it actually cost to build a node similar to the architecture and hardware that was proposed to us, right, by the engineers at Mcity. So we looked at we mapped out hardware for each of the wireframe diagrams. We looked at R&D costs, the range of the nodes, repair and maintenance costs, all that were included. All right, let's go to the next slide. So in the financial model, there's a few different input tabs, and essentially what we're looking for on the depot autonomy savings is what's the total amount of money that could be saved by depot autonomy, and it will allow you to change whether you want to include certain variables in the calculation. So it figures out how much money total could be saved, and then we have the cost. So we have all the input variables related to how much the solution will cost, the size, the hardware costs, whether you're using PoE or whether you're running copper wire to each of the nodes. All that's included, and then it figures out, okay, what's the total cost of implementation? And then we look at the cash flow, and the cash flow, it tells us whether or not the project is valuable to a specific depot autonomy location. So that figures out, your payback period. It figures out your time adjusted rate of return, and then the net present value of the project, which is essentially what is the total value of the project worth to the company if they chose to invest. And then we also have notes and references throughout the model on why we chose inputs or variables for specific things and why we set up the logic the way that we did. So if we look at how depot autonomy can save costs, the solution that was described to us, right, nodal depot autonomy, which is setting up nodes on a grid throughout the factory and the outside area so that they can map where the vehicles are being marshaled and control that like through a central server. We looked at planned maintenance and cleaning events. Unfortunately, when we researched it, they don't clean the delivery trucks very often. They usually do it about once a quarter. So you can't save very much money by driving to and from cleaning events. And planned maintenance events are about every 30,000 miles on these types of vehicles. Especially the electric vehicles have even less planned maintenance, so you can save less money because you're not able to drive those to and from maintenance events and reduce the labor burden. But the biggest chunk of savings that you can get is driving to and from the loading bay. So the way it works is the drivers get in the vehicle, they go and they wait in these waves for a loading bay to open up, and then they're able to go in. If you're able to have the vehicle at the loading bay ready to go for the driver, then they end up saving all that time that they're using to marshal that vehicle over. And then you also have time saved or dollars saved, I guess, by being able to deliver extra packages. So if you were able to save all the time, all the labor from those previous items, how many extra packages can you deliver? What's that worth to Amazon? So we broke it out into two different categories here: the likely savings based on the solution that was presented to us, and then kind of the stretch goals. So the package finding right now, Amazon drivers, they get out of their vehicle once they get to the delivery bay, and they go grab carts, and they drag these carts from the warehouse to their truck, and then they start loading those packages onto the truck. It would be really difficult to automate moving the carts and the packages from the warehouse to an Amazon truck, but there are other facilities where they're using smart carts or these forklifts, and then it would be easier to implement moving those packages from the warehouse to the vehicle itself. And if you're able to save that time, also, then you save money for the delivery drivers and you save money for the warehouse employees who also help marshal the carts from the warehouse to the trucks themselves. And then kind of the hardest thing to achieve would be to actually load the vehicles from the carts. So a lot of delivery drivers have their own personal preference on how they like their packages loaded, how they want to deliver them with the order they want to grab them in out of the back. And so while that takes the most amount of time, so there's the most amount of savings there, it would be the most difficult to automate because you'd have to get some kind of automation that can move in and out of the vehicle that can allow the driver to say, this is my preference, load it front to back on the packages I'm going to deliver that day, top to bottom. They have lots of different preferences for how they do that. But on the right, you can see based on the type of employee, whether they're a delivery driver or a warehouse employee, what the total potential savings is. So total, they can get $2.15 million. But out of the things that you're likely to achieve through the nodal depot autonomy, it's about 430K of annual savings. So this chart breaks down who the savings would go to. So it's the same $2.15 million, but it's telling us, hey, most of that money is potential savings for the warehouse owner. And that's because Amazon is set up in a way that they have these several delivery service partners, contractors, delivering out of their facilities in Amazon branded vehicles. So because they have between 9 and 12 the DSPs working out of one facility, they have a really small amount of savings per delivery service partner. So overall, you want somebody that's vertically integrated. So the warehouse owner would own and operate the vehicles as well, so that they can get the entire pie instead of slices of the pie. But overall, they all benefit because they're going to have decreased turnover. They're going to reduce the burden on their drivers. They're going to have hopefully a more efficient loading of the packages and streamlining the vehicles for delivery. Let's go to the next one. So for the nodes, we looked at how much do the nodes actually cost. And so for the average Amazon delivery center, there would be about 140 nodes required. And that's assuming that you need 25% extra nodes inside than you do outside because of barriers and walls. And I have the hardware that we spec'd out on the left. A lot of that was in conjunction with the engineers at Mcity. And I work in radar system manufacturing for Raytheon. So I do this for a living. I build radar systems. So I also have some expertise in this area and looked at what does it actually cost to assemble these nodes, what hardware would actually work for building these. And I took into account, running the Ethernet to each one of the nodes. If you can keep your power consumption for each of the nodes under 100 watts, you don't have to run copper wire. You can use power over Ethernet to power the nodes. And when I looked at some of the power consumption, it seemed like that was feasible. So you have significant cost savings if you don't have to run copper wire. And out of these, the hardware here, the LiDAR and the radar make up the largest portion of the cost. So ideally, you would want to find ways to, find cheaper LiDAR and cheaper radar and, potentially reduce the number of components that you have. Let's go to the next one. So overall, looking at whether or not it's a good investment, the payback, we had 3 different methods for identifying, is this a good investment for a company? Payback period is the simplest, right? And I think it's one that everybody's familiar with. How much time does it take me to recoup my money on my investment? And when we looked at that, we will have the data on the next slide, but it's essentially telling us, we're making our money back pretty quickly. The time adjusted rate of return is basically saying if you took this money and put it in an investment, like a stock, for example, what's the annual return on that stock? So it's telling you the percentage annual return on your investment. And then the net present value, I'm sorry, we have a question here in the comments. So yes, is installation and retrofitting costs included in the prior cost summary? So installation costs are included. I looked at how much does it cost to run the wire, and retrofitting. So I didn't include costs for like breaking up concrete. I assumed that there was some existing infrastructure available, but I looked at running the prices to run the wire and time to mount the nodes onto existing infrastructure. So no major infrastructure changes, but time to install. All right, and then net present value is the amount of money that you would benefit from. I'm sorry, can we go back one? Yeah, is the amount of savings you would get if from the project overall throughout the life of the project. So for this, I estimated that it was going to take the useful life of the hardware was going to be 12 years, and at that time you would need some kind of major infrastructure change or investment that would basically cause you to reinvest nearly the same amount of money to do an upgrade. So we're looking at the useful life, and we're saying, if I put the money into depot autonomy, how much money do I get back? And it's, it ranges based on the size and scale of the facility, but if net present value is positive, then you're making money on the investment. Let's go to the next one. So the assumptions for the cash flow analysis, I looked at 2 engineers for 2 years to evaluate the solutions, and I included them, basically spending $50K a year on top of their labor rates for research and development costs. And this isn't to come up with the solution. This is for a facility. If I owned a warehouse, I want 2 engineers to go figure out which existing depot autonomy solution is best, and then we're going to go spend 2 years figuring that out, and we're going to buy it and start implementing it on our factory, on our warehouse. So I'm assuming it takes them 6 months to implement the solution, and then those 2 guys are kept on staff to maintain the system. I looked at the annual inflation rate of, I looked at the last 10 years on average, 2.74%. I assumed every year that you would have some amount of maintenance required for every node, and then that you were going to replace 8% of the hardware annually just from different things failing throughout the nodes in the system. And then the weighted average cost of capital for Amazon is 7.67%, which is important for the net present value calculations. And the WACC is essentially how much money does it cost Amazon to spend money? So they have to spend a certain percentage every time they want to spend $1,000. They have to spend an extra 7.7% based on like their labor and other things that's cost them to spend money. Let's go to the next one. So when you look at all that, we analyzed the project in 3 different ways, right? We looked at, okay, what is our net present value and payback period from doing the things that are most likely to be achieved by the nodal depot autonomy. So the payback time for that with the engineer research and development time is 14 years. Not great. And the time adjusted rate of return 1%, net present value is negative. You're not going to make money there. So what this told us is that you have to include getting the packages from the warehouse to the vehicle. If you include getting the packages from the warehouse to the vehicle, then your payback time jumps significantly, right? It goes to 3.4 years. Your adjusted rate of return goes to 51%. Your net present value is $5 million. So you're going to be making money if you can get the packages. You can do the cleaning maintenance, the driving to the loading bay, the delivering extra packages, and you can get automated package finding. It becomes a good investment, right? If you can go even further and load the vehicle, then your payback period is 2.3 years, right? You have 106% rate of return annualized on your investment, and it's worth about $14 million to the average delivery center. And then I'm going to let Gino take it from here.
Yep. All of that analysis that we've described thus far leads us to the question of how scalable is depot autonomy. We have a number of inputs, as Taylor described in detail. However, Three of them stand out the most: the size of the depot, number of drivers and vehicles, and labor rates associated with those drivers. Our conclusion is that depot autonomy is not necessarily feasible with companies that have less than 50 daily delivery vehicles. But as you scale up, the savings and the benefits do grow. Um, Obviously, likely feasible for those with the largest delivery centers. Go to next. How does Mcity capitalize on the development of depot autonomy? I think there's a couple different views or perspectives you can take. You can take it from the entity of Mcity. You can take it from also the perspective of what would be a consumer implementing this type of item structure and process. But Mcity could collaborate in exchange for licensing fees and royalties from technology. They could use their testing ground for fee access and validation services. And then if there's an ability to have an equity stake in spin-offs or licensing fees associated with that. Customers, those being those companies that would purchase, acquire, and or partner, would benefit from a labor savings and operational efficiencies, as we've previously described. There could be a subscription structure. In this case, we've used this a little bit in previous discussions to liken it to think of your own security system in your house and or commercial building where it's on a monthly basis. And subscriptions are in quite in favor and flavor today. So we can move on to the next. As for recommendations, key steps, and some obstacles, there are a couple surveys out there that identified what some of the headwinds are against depot autonomy. In this case, it was warehouse robot adoption, which can act as a proxy. Ultimately, it was budget. So that being a financial investment into the system has been the biggest resistance thus far. We can always take into account the timing in which the survey, which was done, I believe, in 2022, was taken. So in stronger economic and market cycles, that may not be as big of a factor as it is indicated here in this survey. We can go to the next one. Our recommendations, as we've described, for a typical delivery center, you can see about $2.15 million savings. The total addressable market at 1.4 billion. All of our project evaluation methods indicate that it's a good investment for companies that have, again, more than 50 vehicles. Smaller footprints, it would not provide as much of a savings. If we can include the packaging from warehouse to loading bay is going to be a key windfall for in this case would be the consumer, depending on how that's implemented through carts or forklifts. Also, we said that and concluded that a target could be a reduction in hardware and implementation costs. As Taylor indicated, the radar and LiDAR represent the majority of the node costs. So if there's a way to cut costs there and or limit the number of nodes, that could be beneficial. And then a key component to our existing analysis is that power supply under 100 watts per node. So then that way the power supply is provided by the other connection. Market growth potential is favorable. What we're saying here is, the solution needs to be viable within 5 years, because otherwise you're going to lose the ability to penetrate the market due to competition increase and saturation in the market. So it's kind of like, we got to get out of the gate quick and fast. Otherwise, there's going to be no way to catch up. But also, it's an indication that consumers are receptive to the idea. And despite what we were saying earlier in the survey about headwinds as it relates to financial costs, consumers have been open to the idea. Today's a market where everyone is looking forward thinking and trying to capture benefits and capitalize on some of the tech advancements as it relates to automation. So getting access to control of the vehicle systems will be one of the greatest challenges. And we can get into that a little bit deeper as we do in our paper, but there's some liability, there's some brand recognition from those vehicle manufacturers that they don't want anything to go wrong or awry with their system. So for them allowing to lower the security and access to it could be challenging. We can go to the next slide. Obstacles, some of this is through our own reconnaissance and research. Some of this we collected through our interviews. Data storage, we talked about whether it's on-site or cloud-based. Cybersecurity was something that was raised in our interviews, if everything is ultimately linked in that fashion. Competing with large companies of existing and emerging automation technology. Obviously, the biggest example there would be Amazon. They have the ability, they have the funds, they have the flexibility to try to do this in-house. Financially, we discussed initial costs, also rising insurance costs. That is casualty, cyber costs, as we've seen increase throughout many sectors. There's been some recent research and white papers, thought papers about logistically what are some of the biggest obstacles. Power supply is a huge component of this due to not only automation requirements, but someone and a company that is open to automation is also looking at robotics. And so it's going to take significant power supply to implement all of that. Conversion of existing stock. We'll get into some suggestions on the next map team that they could take this even further, but that would be one to do a stock analysis of what facilities that are currently operating have the ability to convert, as we mentioned on the last page, gaining access to existing vehicles, drive-by-wire controls, and then labor union resistance automation. Despite the fact that we have labor shortages, there's still going to be some societal resistance to automation with the idea that it's going to eliminate jobs, which is not the case. That's why we do want to emphasize that it's a solution to the existing environment of a labor shortage rather than an ability to eliminate jobs and labor costs. We can go to the next slide. So guidance for the next map team, further research, more poignant, specific interviews with existing companies and what obstacles they may project and foresee. Depreciation schedule of not only the autonomous vehicles, but the systems. Is there a way to offset some of the initial costs that we've already said are one of the largest hurdles? There's varying opinions on that, but is there a way where we can accelerate depreciation in the early cases or in the early stages? Are there additional use cases for the technology beyond depot autonomy? Sensitivity on the variable inputs, as we've mentioned numerous times, 95 inputs, so we can kind of tighten in on some of those. Insurance costs, that goes both ways. Does the automation allow for workplace safety improvement? And can you pass that along to the insurance provider to decrease premiums? Or I guess you can look at these mutually exclusive too. The reliance on cyber ultimately, is that going to increase potential cyber insurance costs? Scalability of existing stock, we talked about a compliance analysis, total savings, targets, compatibility, security systems, and then adding some more nuances to the model. We can go into the next. So that brings us to our appendix. I think that's probably a good place to take Q&A because some of the detailed questions might be addressed in the appendix, or we can refer to them to help answer any questions that the group may have.
Awesome. You did a great job getting through it. You got 20 minutes for questions and discussion. I think it's been a tremendously useful project to me because it's given me sort of a framework I've been thinking mostly about the technological challenges, but, having a framework, a business framework to think about this um, is critical because lots of good technological ideas go nowhere without a good business framework backing them. Um, you know, can you go to the slide? It's probably somewhere around 25, I think, that was the paybacks. Yeah, that one. Exactly. 26. Yeah. Um, so I think, this is a really important finding here. And I think what it says to me is that we gotta expand the sort of revenue generation side through cost savings to be more inclusive of other things that add value, as well as take a real look at the cost of implementation, how to get that down. And the middle one, savings from previous plus automated package finding, uh, seems to indicate that, the sort of automated forklifts that are bringing the packages to the loading area seems to be a critical part of the use case that we need to include that previously we hadn't included. So that's a really important result. And then on the cost reduction side, those numbers. Actually, could you go to that slide? What was it? 20, yeah, this one. 23. Yeah. So if you just scan down the total cost column there, the LiDAR row and the radar row are the vast majority of the total. Can't do the math in my head, but I think it's like 2/3 of the cost or something like that, right? Um, and so I think that means, our engineering team needs to take a sort of laser focus on those two rows to see what we can do to optimize that better. And the
Yeah,
great
and
thing is, that the map team has created a model that's in Excel that has all of this available. So even though this map team is winding up, we have the tool available to us to do the what if studies.
yeah, it looks like there's a question from Seth.
Yeah, I have a
Okay,
question
cool.
about that first slide you guys were talking about, the one with the returns. Maybe like 20, yeah. So I guess can you remind me first what the delivering extra packages means?
So delivering extra packages means like you're saving time from all of these tasks. Um, what can you do with that saved time, right? There's compounding effects because you could have a driver deliver additional packages that day with the time that he saved, and that's kind of the benefit to the company from delivering extra packages.
Okay, that makes sense. And then I guess my more targeted question about this is that cleaning, maintenance, driving and stuff is probably quite a bit of technical work, and I wonder if in your estimation it's like that part of this is not worth pursuing if
So
the
it's
package finding, or am I misinterpreting that?
it's a really small part, but if you can get the vehicle to drive by itself in a controlled environment, it's an easy cost savings to get because the way that they clean and do maintenance is for cleaning, for example, they'll hire essentially a power washing company to come on site and wash all the vehicles in 1 or 2 days, right? And so what you're having the vehicles do is just say, hey, drive to parking spot 12 and sit there and you're going to be cleaned and then drive back. So it's super easy savings to get if you can achieve driving it from point A to point B, then you get that savings.
Okay, thanks.
And, I think, the other thing that was a huge learning for me from this map project is, the fact that we got to sort of widen who we talk to. Amazon's probably, a difficult first target because they're already heavily invested in warehouse robotics and they outsource the driving. So the cost savings for the, labor efficiencies um, are not directly with Amazon.
Yeah.
Um,
What One thing that
where
could
the
be
costs
interesting,
are.
yeah. So Amazon uses they have a Kiva robotics division. They bought a company that does robotics essentially, and they have these little robots. They look like Roombas, essentially like really big Roombas. So maybe like 3 foot in diameter Roombas that are maybe a foot off the ground. And the way they work is they go under carts for Amazon, and then they raise up. So they lift the cart up, and then they can move the cart like that. Um, and if you could get your depot autonomy to integrate with the Kiva robotics and have them move the carts with the packages on it to the right loading bay because you know where the vehicle is going to be, that could get you that savings at minimal costs.
I have a question. So in this analysis, I'm assuming you have made the assumption that vehicle is basically loaded in the morning and then comes back only in the night, right? It's like one time thing.
Yes, yeah,
So I guess I think in any of the, at least based on what I have experienced in this space, the biggest bang for the buck you can get is when you have continuously moving vehicles, right?
yeah.
Have you thought about how to change the current operation so that there are just more vehicles moving in the depot all the time? And I don't know the answer.
Mhm.
Maybe that's where there will be some keys to unlock.
Sure. So Amazon had decided that their most efficient operating flow, right? They don't want to deliver packages overnight because they normally ring the doorbell. They don't want to wake people up. The earliest they start delivering packages is during the holidays, and they only do it during the holidays. It's like 5 a.m. And then every other time of the year, they're delivering after 6 a.m. Until I think it's 8:30 or 9 at the latest, right? So they don't want to deliver packages overnight. There are other companies that do, but if you're looking at last mile delivery, you're mostly going to be working in the daytime, and most of the time, those vehicles, each one is going to go through the loading process once per day. There are some that load twice per day, or they have a breakdown and they need to go load another vehicle or something like that. But they load in waves, right? So they have all of them come in, load up, and then drive out. And Amazon's worked through that that's the most efficient process for them. But there are other places that have traditional loading bays. And I do think you could get more savings that way because you're having more labor intensive operations because you're going to have two warehouse workers and the delivery driver loading that vehicle as quickly as possible, getting it out of the loading bay and moving on. So you're going to have more labor savings, from that type of operation versus the wave operation.
You know, maybe they can have smaller vehicles instead of large vehicles.
Yeah, yeah, exactly.
I got a question about the middle graph here where there's savings from getting the packages to the trucks. Does the hardware cost increase in that case? Because from the chart, it doesn't look like it does.
So in our costs, we don't have hardware associated with like moving um, the packages. Essentially, like we're assuming the vehicles have drive-by-wire capability already, right? So for the trucks, we're assuming that they already have drive-by-wire, or you're going to install some kind of system that would be, it's basically something that would push the pedals and turn the wheel for you. That's adding drive-by-wire capability. So for this analysis, we didn't include the ability to, we assumed all vehicles have drive-by-wire. So forklifts, in this case, we can imagine a forklift moving the packages to the trucks. I assume that forklift is already controllable, so your hardware costs wouldn't increase.
What about nodes within the warehouse?
So we already have nodes like in a grid throughout the warehouse that's already included in the base hardware costs. And the reason we did that is because you basically the vehicles are in a lot of cases for Amazon, the vehicles drive into the warehouse and they have like a big open floor space where all the vehicles line up. So we assumed we had to have nodes all throughout the warehouse already.
Okay, thanks.
Yeah, and if we had like automated forklifts for moving packages, we may need like a forward-looking camera on the forklift or something, and then the supplementation from the infrastructure nodes.
I did do some research on what it would cost to add drive-by-wire capability to trucks and like 18-wheelers. That's what people are doing now. And it looks like it was running about like $1,500 to $2,000 a piece to add some hardware that's capable of turning the wheel and operating the pedals. which is cheaper than I was expecting. But I couldn't find anything for automating forklifts that can be added retroactively. There are companies that sell, that are researching automated forklifts in totality, but not retrofitting forklifts for that capability.
Yeah, and I think, another thing, I mean, there's the reference to a future map team. So just for everybody's awareness, I put in a proposal to the full-time MBA program at the Ross School, which starts another round of map projects at the beginning of March. So if we get another Ross team to pick our project and continue on, we would have a 40-hour a week full-time MBA team working on it, mainly in March, April, ending sometime in May. But one of the things that we were thinking about and sort of structuring it around was this idea that the more vertically integrated companies might be a better target. And I know some of them, just from some past experience, they have wash racks on site and they have charging stations on site and things like that. So they may be, in a different space relative to, if you had a wash rack, you'd probably use it more, right? And so then the cost of cleaning and maintenance, getting the vehicles there, the cost of getting them to chargers and off of chargers, those kind of things could be more relevant in some of the other companies as well. So, taking this sort of really good framework of here's what we're thinking of making and here's why we think it has value. And then, having a much deeper dive with individual customers, like, somebody who actually runs the DHL depot or the UPS depot, that kind of thing, I think is something I'm really interested in as a next step. And we'll see how the proposal process goes, but between now and then, I think the most interesting thing I'd like to do is to take sort of another look at the scope of the engineering work that we're doing. What's the use case we're going after? Can delivery of packages to the loading area be part of that scope, as well as the cost model of what does it cost to implement this, and are there options for reducing specifically those radars and camera line, or excuse me, radar and lidar lines, because clearly that balloons the cost pretty significantly.
Yeah. And one thing that I want to mention that I don't know a lot about, so I didn't include in the model is data storage, right? I have like central compute costs and how much central compute, is going to take to install. And I kind of work through what that hardware would be. But data throughput, how much data you're collecting and sending back to the central server and how much data you need to send back, make sure those align with the capability of the, power over Ethernet standard. That's something that needs to be looked at. We got
Other
about
questions, comments?
5 more minutes.
I guess one thing that's unusual is looks like a lot of the sensing is fixed rather than being on vehicles. Has an analysis ever been done to compare the relative costs?
So we assume that the vehicles already have onboard sensors, right? That's the drive-by-wire capability. I mean, all new vehicles, especially delivery vehicles, are coming with the drive-by-wire capability, cameras all the way around. And there's companies that are installing these retroactively for Amazon to monitor their drivers. So they really are into driver, basically big brothering, monitoring their drivers.
But aren't the nodes fixed and those have radar and lidar and cameras?
Yeah, that's correct. Yeah. So we're assuming that those vehicles are reporting data back to the nodes and the nodes are also like checking their position as well, and everything's being reported back to the central computation.
Yeah, so the high level context is there's three types of system for doing this. The type one is the vehicle centric one, which I think is what ISEE and Outrider and the others are doing. Type two is the infrastructure centric one, like what Bosch implemented at the Stuttgart airport, where the infrastructure does everything. And then what we're targeting is the middle one, which is type three, where the infrastructure does what it's good at and the vehicle does what it's good at. And together you can take basically what would you could think of as a level two autonomy vehicle and be able to marshal it autonomously through using assistance from the infrastructure sensing. And the hope is that net that ends up being a lower cost solution overall, and additionally a more safer, more efficient system. So that's the sort of research idea that we're investigating here. Nobody that I'm aware of is going after the type 3 systems at this point like we are, which is what makes it an interesting research challenge, right? Because there is some system of system issues where you have to have these different companies collaborating quite closely to implement an integrated system. And so that's why this is a useful and interesting research challenge to go after.
Yeah, the wireless communication is this thing that would be difficult, or one of the big challenges, I think, in the hybrid, or the system where you use a lot of the infrastructure, because it seems to be a challenge is maintaining good connectivity.
I mean, the good
Yeah.
thing about having a depot is that it's a controlled environment, so you could add routers where you need to, and they're not going to be out on the open road. So the connectivity is a little bit less of an issue where you're controlling the environment.
Right. And I think generally what we've seen in connectivity is that the telecommunications companies are investing massively to make bandwidth better, latency reduced, fewer dead spots, all these sorts of things. They're investing, irrespective of things like depot autonomy, that money is already getting invested so that a school bus full of children can download Netflix simultaneously. And so in some ways we are just beneficiaries of all of that, the great innovation that's actually happening with 4G, 5G, 6G and beyond.
All right. I think we're about out of time, but Greg, we really appreciate you setting this up, and it's been a lot of fun, actually. It's a really interesting project. So um, we will send you a copy of the presentation that we showed today, and then we're still working on the final report, but we'll probably have that to you early next week.
Yeah, awesome. This has been exactly what I wanted from the project, and I really think this team's done a fabulous job. You've taken something that was sort of a rough hunch that I had, and you've really put a framework out there that now we can go from just sort of an intuitive feeling that there's probably money to be made to an actual framework where we can really fairly rigorously evaluate where the opportunities are, or where they're not, right? So that we can make sure we're efficiently using resources. So really appreciate what you've done, and really thanks a lot to the team.